Okay, we're live. Welcome to Algebra with Doug. It is early October, it's cold outside, and that makes me glad that I'm in here with you doing some math, because when I do math for an hour, which is what I intend to do right now, my brain is working so hard, I guess somehow it generates heat, because afterwards I don't feel cold. So that's going to be the trick that I will do today. Mocha is not here, she's upstairs, and the reason I didn't bring her downstairs for this lesson was because I knew that there was going to be some information involving negative numbers, and I asked her, what's a negative number? Explain to me what a negative number is. And you know what she did? She didn't say anything, she just sort of stretched out her front legs while looking at me, and then she stretched out each of her hind legs one at a time, stretching them way out behind her. So I thought, okay, that's cute, but she's not being that helpful, and for a beautiful assistant she should be more helpful than that. Sometimes really I think that she's a cat, or that she thinks she's a cat, because that stretching thing, that's cat-like to me. Anyway, so this is a Nottingham Forest shirt. They are a team from the English League. It's a kind of a cool logo with the tree, and I like it. And that's enough of all the non-math stuff. Now I'm going to get into the math stuff. We're going to start this week by talking about the idea of absolute value. What is absolute value, you say? Absolute value is this thing we do in math. We use these two straight lines on either side of the number, two straight vertical lines, to symbolize absolute value. And what it means is that we're forcing the number that's between the absolute value lines to be positive. So the absolute value of 5 is equal to 5. Well, that seemed obvious. The absolute value of -5, though, is also equal to 5. So you could see it as being a mathematical operation, if you will, where we want to know the size of the number, but we don't want to consider the sign. We just want to pretend all numbers are positive if we're doing this. Why would we do that? What's a situation where I might think that applies? Well, one thing I'm going to do is I'm going to draw a number line. And I'm going to make this number line 4 feet wide. I'm trying to make the ruler straight. So this is the yardstick, so that's 3 feet. And I'll have to make it a little longer. Let me divide it though. So there's 24 inches, and here's 12 inches. Now I'll make it a little longer. Well, we know how much longer. I'll make it 1 foot longer. And bear with me while I try to do this without making too much of a mess. There, now it is 4 feet long. Okay, so I'm doing a number line and I've made it 4 feet long. I'll put my 0. I'll show 1 foot. I'll show 2 feet. I'll show -1. I'll show -2. And then we ask ourselves the question, okay, how far is it, if I measure, how far is it from 0 to 2? Well, we already know the answer. It's going to be 2 feet. I made the size of the spaces between each consecutive integers 1 foot. So this is a foot, that's another foot. The answer is 2 feet. Straightforward. What about how far is it from 0 to -2? Okay, so therefore it's going to be -2 feet, right? Except that doesn't really make sense. We really care about the distance when we're saying how far is it. That is 2 feet. Even though I'm going in that direction, it's still 2 feet. So I can say from 0 to 2 was the absolute value of 2, which is equal to 2 feet. And from 0 to -2 is this going to fit? Good. Also, the absolute value of -2, which is 2 feet, in order to get an answer that makes sense. So this is an idea of how we apply absolute value. It's just a little example I tried to come up with. And we are going to talk a little bit about the absolute value as we go through this week's lesson, and that's why I wanted to mention it right from the beginning. Now, what is next on my list? Now we're going to do some inequalities. So what are inequalities? Inequalities are kind of like equations, but we use inequality symbols instead of equal signs. So we're using the less than sign, the greater than sign, the less than or equal to, and the greater than or equal to signs. So I will erase this. And we'll start going some algebra. Not very different from what we were doing last time. We're just adding an extra little thing to it. So, a situation where an inequality would apply in real life. I was trying to think of a good one. And one I thought of is, okay, so in a restaurant, if you're ordering food from a restaurant, for instance, you might see a chance to get a free item. So what if the rule is a free item, but that's only if you spend at least $20. Takes a lot more time to write it than it does to say it. Seems to take more time to write it than it does to eat the item. Okay, so we can all understand a situation like this. If you spend at least $20, you get the free item. Maybe they give you a list of certain items from the appetizers menu that you can get for free. I've seen this before with restaurant deals. So that means we are applying the concept of an inequality. If X is the amount of money you spend, if X is less than 20, then you get no free item. A bit more chalk, thank you. But if you spend greater than $20, then yes, you get a free item. What if you spend exactly equal to $20? Well, we have to read this carefully. What did they say after all? You must spend at least $20. So at least indicates that $20 even would be enough. So that's also a yes, you will get a free item. And of course we can combine these two symbols and just say, if X is greater than or equal to 20, then it's yes, you get a free item. This is a logical situation that anyone can understand. So here I am applying the idea of an inequality in a real life situation. Now I'm going to move on to my second page, and I'm going to check the time. I have certain time limits I'd like to abide by for each of the pages in my notes. I'm going to start showing some simple inequalities like this, where we're not really doing the steps of algebra to them yet. But I'm going to start showing them on the number line. Being able to show these on the number line is a basic skill that makes it a lot easier to understand the answers you get when you do algebra involving inequalities. So I'll erase this. While I'm erasing, I always encourage the students to stand up and stretch if you need to, or get a sip of water. And I myself need a sip of water, so I'm going to take one right now. Okay, that's good. Let's graph some numbers on a number line. Now I had X greater than 20 before, but it's a bigger number. I want to start with some nice small numbers when I start a new topic. So how about X greater than 4? We want to be able to graph this on a number line. Well, we'll draw our number line. And I apologize for not using a ruler. I'll try and make my number lines not be too messy. And I like to always show my 0 as soon as I start drawing a number line. And then I look and I see, okay, I have a 4. I have to make sure 4 fits. So the number line I drew before that only went up to 2 and down to -2 wouldn't really work very well with this inequality. So I'm going to put the lines a little closer together and go at least up to 5. But I also want to go at least down to -5. Now, I might not need these negative numbers for every inequality I want to graph, but I am going to show them because they are important and we will have to deal with them, and we can't really always choose what type of numbers we get to use when we are given a number line. So X greater than 4. I think I'll make this a little bigger because it wasn't going to show very much, because I'm looking for the numbers that are greater than 4. What numbers are greater than 4? We're operating within the universe of real numbers, so even numbers like 4.1 or 4.03 are greater than 4. So the way we show that on the number line is we put a circle around the 4. Greater than means we're going in this direction, so we use shading. And then we show that it is going to continue onwards. So I did not put a solid circle on the 4. This is one of the details that you have to be careful with, of course, because this does not say x greater than or equal to 4. It says greater than 4, so 4 doesn't count. The open circle shows that 4 doesn't count, but that's the way the shading begins right after the circle shows that all of the numbers in between 4 and 5 do count. And that is a good way of being clear when you are asked to graph something like this. So that's actually just fun. I like graphing things on the number line. I will do a few more. We have to try all sorts of situations to make sure we feel comfortable, because there can be positive numbers, there can be negative numbers. There can be greater than, there can be less than. There can be the greater than or equal to, or the greater than, the greater than, there can be greater than, or they can be greater than or equal to. That was messy, but I managed to get it out in the end. So let's do a few more, and it won't take too long to draw these. It doesn't take too long. So it's good to get a bit of practice. I am erasing my whole number line, instead of trying to just erase where I put the shading. My next one that I'd like to do, how about x less than -3? Okay, now we're using the negative numbers. I'll draw a number line, I'll put a 0, I make sure that I show -3 and some numbers on either side of it. So there's -1, -2, -3, -4, I'll put a -5 in there as well. And I'll show 1, 2, 3, 4, 5 as well. 1, 2, 3, 4, 5, doesn't take as long. Less than -3, we have to put a circle on -3. Is it going to be a closed circle or an open circle? This is less than. It's not less than or equal to. Number equal to 3, which is 3, doesn't count, so it's an open circle. Less than -3 means this direction. So we're not looking for smaller looking numbers like 2 and 1 that seem like they're less than -3. No, we're looking at integers that are less than -3, and that means we're going in this direction. With number lines, it's quite easy to remember because less than has a tendency to be to the left. Okay, so I'm going to shade the numbers that are less than -3, and it does continue onwards, so I'm showing that. I've graphed it. Not so hard to do. A negative number doesn't complicate things too much. Let's do a few more. How about x greater than or equal to -2? X greater than or equal to -2. Showing my number line, showing my 0, putting a -1, a -2, making sure to show some numbers on either side of -2. How about, there's my 0, 1, 2, 3, 4, that's enough. -2 is my number, that's where I put a circle. Do I fill in the circle? Yes. This is greater than or equal to this time, so I need a closed circle, a shaded in circle. Greater than means that way, so I am shading in that direction. And I show a dot, dot, dot to show that it keeps going. This is fun. It is easy, but if you think it's too easy, then you're asking for trouble because it can be a little tricky. You'd think there wouldn't be so much variety, but there's actually quite a lot of variety in how we can ask a little question like this, ask the student to graph something like this. I actually came up with 8 different ways. So I've done 3 of them already? Yes. I'm going to do all 8. How about x less than or equal to 1? Why is it so many different types of question I can ask? Because of the combination of less than or greater than, or equal to, or without the or equal to, positive number, negative number. We have choices in all 3 of those categories, and it leads us to 8 different things that can happen. So x less than or equal to 1. Well, for this number line, I don't have to show very many numbers at all because it involves the 1. So I'm just going to show 1, 2, 3. Well, there's room for a 4, so I'll show it. -1, -2, -3. I won't even show the -4. There wasn't really enough room for it. Show my 0. Okay, 1 is my number. I put a circle on there. Am I filling in the circle? It's less than or equal to, so yes, I am filling in the circle. Less than means this direction. So I am shading in this direction, and I have to keep shading all the way to the end of the part of the number line I showed, and then show that it continues. I did it. Not so crazy, kind of fun. Let me do the other 4 examples. I'm just doing them really quickly. x greater than negative 5. Draw my number line, put a 0. I have to make sure negative 5 fits, so I'm going to put the numbers fairly close together. It's hard to fit them because of the negative signs on this side. But I can do it, negative 5. I make sure at least negative 6 shows so that the numbers on either side of negative 5 are showing, so it's clear what the answer is. And then I can put 1, 2, 3, 4, 5. That's enough over here. It is negative 5, that's my number, so that's where I want to put a circle. I am not filling in the circle. It is greater than, it is not greater than or equal to. And greater than is this direction, so I'm shading in this direction. I ended up doing quite a lot of shading, quite a long number line, and I put dot, dot, dot to show that it keeps going. Okay, how about the next one? X less than 6. Numbers are getting a little larger. It's because I'm trying to avoid repeating using all the same numbers. X less than 6. What can I do differently here? How about if I scale my number line, instead of just going up by 1s, I could go up by 2s. 2, 4, 6. Yes, we can do this. We can choose to scale our number lines differently, and this is the reason to do it. When you get numbers that are getting a little larger, in order to fit them without having to draw a really long number line and go off the page, you can go up by 2s or by 5s or by whatever number is convenient. Negative 2, negative 4, negative 6, negative 8, that shows enough. Okay, 6 is my number, I put a circle. Do I fill it in? No. It's less than, it is not less than or equal to. Less than means this direction, so I'm shading over here. And I put dot, 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 it keeps going. I have graphed it. Only 2 others. I wanted to try one that's a little different looking, so that's what the next one is. How about x greater than or equal to 0? Can I use 0? Of course I can. 0 is a number. It's on the number line. I can show it on the number line. It tends to be the first number I label on my number line. And I don't really have to show very many digits to be able to show this inequality. So I'm going to put nice big wide spaces. 1, 2, 3, negative 1, negative 2, negative 3. 0 is my number, I put the circle on it. Do I fill it in? Yes, I have to, because it is greater than or equal to. So 0 is included in the answer. Greater than means that direction, so that is the direction that I'm shading. And I put the dot, dot, dot. Yes, even when we have 0 as the number in our inequality, we can still graph it. That is fun too. One more. And I'll give one that has larger numbers. Talking about this thing, about scaling our number lines so that the numbers we have will fit. How about x less than or equal to, what number did I have? Negative 20. Negative 20. Okay, I don't want to draw a number line all the way to the next block, so I have to scale this. I'll put 0, and what I'm doing is I'm just going to go up and down by 10s. So I'll make that 10, 20, 30, negative 10, negative 20, negative 30. I can even show negative 40. I have just enough room, make my number line a little bigger. Okay, negative 20 is my number. That's where I put my circle. It is or equal to, so yes, I am filling it in. It is less than, so it is in this direction. I'm able to shade. I can put dot, dot, dot. So even when we have really big numbers, if we had a number like x is less than or equal to negative 2000, we could still do it. We just have to choose how we scale our number line a little differently so that we can show the numbers. I like my number lines to always have 0 showing, even if the question doesn't really involve 0. Okay, what is next on my list? Okay, we're going to continue to graph on the number line, but we're going to put the 2 concepts that we've talked about today together. And what was the other concept? It was absolute value. So we're going to talk about graphing some absolute value statements. And again, we start with simple ones with small numbers. So here we're going to put the absolute value of x is greater than 2. I want to be able to show that on the number line, but first I have to know, well, wait, what is the answer? the answer is a little bit more complicated than it was before, because now we have to apply the concept of absolute value at the same time that we're applying the concepts of the greater than and the less than, the or equal to, etc. So the absolute value of x is greater than 2. It means that after I apply the absolute value operation to my number, if the answer is greater than 2, then it's true for this statement. So let's try it with a few numbers. How about the absolute value of x? Sorry, I'm not going to put x. I'm going to substitute for x. The absolute value of 3. Is the absolute value of 3 greater than 2? Yes, it is, because the absolute value of 3 is 3, and 3 is greater than 2, so that works. The absolute value of negative 4, is that greater than 2? The absolute value of negative 4 is 4. And 4 is greater than 2, so that one worked as well. How about the absolute value of negative 1? Is that greater than 2? Well, the absolute value of negative 1 is 1. Is 1 greater than 2? No, it doesn't work. So that gives us an idea of what our answers are going to look like. And then we can start looking at the pattern and realizing what's happening here. Whenever I have a value that is larger than 2, if I ignore whether it's positive or negative, if it's larger than 2, 3 is larger than 2, that worked. 4 is larger than 2, that worked. But when I get values that are smaller than 2, it's not working. And that's enough so that I can see what I'm doing and I can graph the answer on my number line. Because there are a lot of right answers, there are a lot of correct answers, there are an infinite number of correct answers. I can't find them all by plugging, so I want to answer the question by graphing. Let's draw a number line. And again, I look at the number I have to see, okay, how should I label my number line? I'll put a 0. I want 2 to show. So there's 1, there's 2, there's 3, there's 4. 2 shows and numbers on either side of it show. Should I bother showing the negative numbers? Yes. It's starting to become really clear that I do need to start showing, I do need to continue showing the negative numbers. So negative 1, negative 2, negative 3, negative 4. Now I'm starting to show the answer. Now, what happened there was all the values that were bigger than 2 were part of the answer. 2 itself, I didn't try 2 itself, I'm going to try it. Is the absolute value of 2 greater than 2? The absolute value of 2 is 2, right? Is 2 greater than 2? No. If it had been greater than or equal to, it would have been a yes. So that didn't work, that's a no. 2 is not part of the answer. And it's back to the same thing we were doing when we were just graphing on the number line without involving the absolute value. I realize that my number that I need is 2. But I realize that I don't want to shade inside the circle. I want an open circle there. And then what numbers were working again? 3 worked, negative 4 worked. Negative 4, okay, 3 worked, 4 worked. All the numbers that are larger than 2 are working. So I'm going to be shading over here. And it will go on and on, so I'm going to put the dot, dot, dot. But what about on these numbers? Remember, negative 4 worked. Negative 4 was a correct answer. So that means I need to put a circle around the negative 2 as well. And let's try negative 2. I haven't tried that one. The absolute negative value of negative 2, is it greater than 2? Well, the absolute value of negative 2 is 2. The same thing happened. I'm saying 2 is greater than 2. That's not working, no. So again, negative 2, I am not going to shade inside that circle. It's not part of the right answer. But all these negative numbers that are larger than 2, the negative 3 and the negative 4, when we plug those in, we saw before when we were plugging in, they were giving us, yes, check marks. Yes, it was part of the answer. So I am going to shade over here, and I'm going to show that it keeps going. We have an interesting little number line here that has 2 sections shaded. That's cool. That's different. That's neat. There's something about it that's sort of crossing that border between math and art, because there is symmetry here. And I like that because I love noticing the overlap between math and art and math and music. So that is a cool little question. Seems like something small, but we really had to do a lot of little details in order to be able to get our graph to show our answer. This is the answer. I need to do a few more of these. And I'm going to keep on testing values the way I did here, at least at first, because I want to start understanding the patterns before I start trying to apply the patterns. So it takes a little bit of thinking. Let's try again. We see how much variety you can have if you have the different symbols, if you include the or equal to or don't include it, if the number that's in the statement is negative or positive. So we want to try some of the different combinations and see what happens. This piece of chalk is finished. I will start a new one. Load it into this chalk holder. Okay. How about, trying to see what I wrote here. It's a little bit messy. The absolute value of x is less than or equal to. Less than or equal to. So now we have less than instead of greater than, but we also have the or equal to. And the number that's on the other side is 3. I want to graph this. I will graph it. I'm going to even get a number line ready. And what should I do with my number line? I'm going to show my 0. I like that. I want my 3 to fit. And I want numbers on either side of the 3 to fit. So I'm going to scale it like this. And I'm going to show the negative numbers as well. I think I've learned that it is a good idea to do that. Okay, now let's start plugging in some values. We have this thing going where we look for some numbers that are larger than the number that we have here. So numbers larger than 3, like 4 and 5, can be useful. But also -4, -5, these numbers can be useful. And of course, numbers smaller than 3 can be useful. 2 and 1, -2, -1. Let's try a bunch of them. The absolute value of -5, is that less than or equal to 3? Well, the absolute value of -5 is 5. Is 5 less than or equal to 3? No, didn't work. The absolute value of -4, that is equal to +4. Is 4 less than or equal to 3? No, that's not working either. How about 3? It's a good idea to use the number itself, but I'm going to try -3. -3. The absolute value of -3, is that less than or equal to 3? The absolute value of -3 is 3. And this time we have a yes, thanks to that little or equal to in our symbol. So -3 is working. -5 didn't work, -4 didn't work. That means that -5 and -4 won't be part of my answer. -3 will be part of my answer. I start seeing some clues as to what I'm going to do here. Here I am putting my circle on the -3. But then I think, wait, am I going to put a circle on 3? I have a feeling I am. But just to be sure, let's do some plugging. How about absolute value of 5 less than or equal to 3? Well, the absolute value of 5, of course, is 5. And 5 is not less than or equal to 3. That didn't work. 4. The absolute value of 4 is 4. Is 4 less than or equal to 3? No, that's not working. 3. The absolute value of 3 is 3. Is 3 less than or equal to 3? Yes, it is, thanks to that or equal to. So again, I see a reason why I want to put a circle on this 3. And all of these larger sized numbers, the 5 and the 4, the -5 and the -4, were giving me no, they're not working. So I have a feeling that the numbers in here, where the size of the number is smaller than 3, the 2, the 1, the -2, the -1, I have a feeling those are going to give me yeses. And I'm going to be shading in the middle here. But let's make sure. How about the absolute value of 2? Is that less than or equal to 3? Well, the absolute value of 2 is 2. And 2 is less than or equal to 3 because it's less than 3, so that's a yes. -2. The absolute value of -2 is 2. Less than or equal to, is 2 less than or equal to 3? Yes, it is. So we have another yes. We have a lot of evidence now that what we're going to be doing is we're going to be shading in between the -3 and the 3. So, interesting. Why did it happen this way, where we have just one block of shading instead of 2? Because we had a less than symbol instead of a greater than symbol. And this is why it's good to do a bunch of these to practice, because then you start feeling confident that, okay, I noticed this happened once. Does it always happen? If I practice enough, I'll be able to figure out for sure if it always happens. Is this symmetrical? Yes, this is also symmetrical. Is it beautiful and cool and kind of almost art? Yes, it is. If I were to get a ruler and use some color, I could turn this into something prettier. But it's already looking pretty to me because I like being able to show the answer to a question graphically. That is cool. Number lines are cool. Okay, but I want to do a couple more and try a little bit more of that variety that we talked about, all the different combinations of things that can happen. There's a lot of stuff on here, but now I'm going to start doing less of this plugging and more of the thinking and understanding to be able to create my number lines. I still think it's a good idea to test with at least some numbers, so I will continue to do that. This is interesting. It feels like a completely different topic when we compare it to what we were doing in the last couple of lessons. But is it? Is it really a completely different topic? Well, I guess that remains to be seen as we meander our way through the remaining part of this lesson. We're around at the halfway point. How am I doing for time based on my planning? Let's see, page 1. I'm doing okay for time. Okay, so how about the absolute value of x is greater than or equal to 5. I'm going to start by getting my number line out, putting a 0. I have to make sure 5 fits, so I don't want to put the numbers too far apart. I could count up by 2s if I want, but I think what I'll do is just put the dashes a little closer together. I'm going to have to make this a little longer because I want 6 to fit. This is 1, 2, 3, 4, 5, 6. Make sure the numbers on either side of 5 fit. -1, -2, -3, -4, -5, -6. Takes a bit of time, but it's worth doing because it makes your answer clear. Okay. Now, should I put a circle on the 5? I have a feeling I should, and I think I'm going to go out on a limb, and I'm going to start by putting a circle on there right now. Should I put a circle on the -5? Again, I might be going out on a limb here, but I think I will put a circle there. And then I have the or equal to. So I'm even starting to think maybe I should go out on a limb and shade in that circle. Both of them. We'll see if I'm wrong. I'll admit it later if I turn out to be wrong. Greater than. Remember, that was our first example when we did one of these. It was a 4 or a -4, but it was a greater than. Is it a -4? No, it wasn't a 4. It wasn't even a 4 at all. It was a 2. So I'm just remembering the wrong thing. Greater than, though. The numbers that are greater than 5, when we think of greater than 5, it's really easy to figure, okay, that's going to be over here. But greater than -5, well, it's a little bit more iffy when we think, because we know that these numbers way over here are actually less than these numbers. But don't forget, there's an absolute value symbol involved. So I'm going to do a couple of examples of plugging just to make absolutely sure. I'm going to try something that's in between the two dots to see if it seems to be giving me an answer that's correct. I will try -2. The absolute value of -2 greater than or equal to 5. The absolute value of -2 is 2. But is 2 greater than or equal to 5? No. So I'm starting to see evidence that the numbers in between the 5 and the -5 are not going to work. How about numbers that are outside of the 5 and the -5? I'll try 6. The absolute value of 6 is 6. Is 6 greater than or equal to 5? Yes, it's greater than 5. So that means 6 is part of my answer. I have a feeling that I can start shading now. But I'm going to try -6 as well, just to be sure. -6, absolute value of -6, is it greater than or equal to 5? The absolute value of -6 is 6. Well, that looks like that, doesn't it? Is 6 greater than or equal to 5? Yes, it is. So therefore, -6 is also part of my answer. And I start seeing patterns. When there's a greater than symbol, or a greater than or equal to symbol, I find myself shading two different regions of the graph outside of the number of the size that I have here. When it's a less than or a less than or equal to sign, I find myself shading in between the two, that number, the positive and negative versions of that number. Interesting. So yeah, the pattern is useful, and I think the pattern can be trusted. But I think this idea of plugging in a few values is a good idea. I have some things to, okay, I saw something on my device and I read it and it doesn't matter right now. What it does matter right now is I've been talking for a while, so I need a sip of my fizzy water. Okay, I think I'll do one more of these. This is fun. How about... Nearly fell over there. It's because it's cold. And because it's cold, I'm wearing slippers. I'm in the basement. But just wearing slippers, it feels like I'm skating. Okay, how about absolute value of x is less than 1? Okay, I'm going to start drawing my number line right away. I'm going to show a 0. Oh, that's handy. It's a 1. This doesn't look like a 0. I don't know what it looked like, but now it looks like a 0. It's handy. It's a 1. It means I don't have to label too many numbers. I'll just put 1 and 2 and negative 1 and negative 2. I think I have to put a negative 3 here. The line was long enough. So I'll also show a 3, make that a little longer. Okay, now we can start answering our question. Having some confidence based on the experience of the last 3 examples, I'm going out on a limb a little bit again. So I see the number 1. So that makes me want to put a circle on the 1 and on the negative 1 because it's an absolute value problem. If it didn't have the absolute value symbol, I wouldn't be putting 2 circles. And it's less than, it's not less than or equal to. So I don't think I should shade in there. And what happened the last time we had less than? We ended up shading in between the 2 circles. Is that going to happen? Should I shade right away? I'm going to try it. And if I'm wrong, I will have a red face while I erase and redraw it. But let's do some, well, I have my answer. I actually went all the way to giving the answer this time. So let's see if my answer is correct. We'll try negative 2. The absolute value of negative 2, is it less than 1? The absolute value of negative 2 is 2, so we have the statement 2 is less than 1. That's not true. So 2 is not, where is it? Negative 2 is not part of the answer, so it's good that I didn't shade over there. How about positive 2? The absolute value of positive 2, is that less than 1? The absolute value of positive 2 is 2. Is 2 less than 1? No. So I didn't shade where the 2 is, and I'm feeling more and more confident. I think I'm going to try this 0, though. The absolute value of 0. The absolute value of 0 is 0. Is 0 less than 1? Yes, it is. So it needs to be shaded. Do we trust 0 when we do this? I feel like I can trust 0, but I think maybe I should do one more. We know that all these other numbers, all the decimals and fractions between 0 and 1, for instance, between 0 and negative 1, they're all involved here. That's why we're using shading. We're working within the universe of real numbers. So let's try negative 1/2. The absolute value of negative 1/2, is that less than 1? Well, the absolute value of negative 1/2 is going to be positive 1/2. Is that less than 1? Yes. Half is less than 1 because half a pizza is less than 1 pizza. Fractions are pizza. Okay, so therefore that is a yes, that is a true statement. So that means negative 1/2 should be shaded, and it is. I feel confident that I have the right answer. And that's the last example I'm going to do of those. That's the end of this page. Okay, let's move on to something else. This is fun though. I could do these all day. Maybe it's because I end up drawing something. And I know when I'm a student and I'm doing this, I actually will use a ruler. And I like to get a little bit fussy and make sure it looks really nice. Something about making my work look nice makes it look organized, and that makes me feel organized. I think it's something to do with that. Now we're going to do, let's see here. Am I on camera? I don't want to walk right off camera while I'm standing there thinking. I'm going to do what looks like the same question twice, just to compare them. Remember, we've been working on algebra. Algebra had all of these steps that involve moving things back and forth across the equal sign. But what about when you have an inequality instead of an equal sign? Well, we're going to find out by doing a question that only has, we're going to do it twice, and there's only going to be one small difference between the two. So how about 2x plus 1 equals 9? That looks like some of the ones we were doing last time. And 2x plus 1 is less than or equal to 9. Equality? inequality. Let's do this one first. This is the one we're more familiar with. What do? We have our x and we want it to be alone. It's being multiplied by this 2, but it's also having this 1 added to it. Which one do we deal with first? We deal with that plus 1. We do the opposite of adding a 1, which is to subtract a 1, which we do from both sides. These cancel. We have 2x equals 8. Now our x is being multiplied by a 2. We do the opposite. We divide by a 2. These cancel. X is equal to 4. We have our answer. We knew how to do that. That's just a review of some things that we were doing a lot of last week. Two-step algebra problems. This is also a two-step algebra problem, or is it? Let's find out by doing it. It's very similar. Should we do the same things? Do we do the same rules? Yes. Nearly everything is going to be the same. So let's try it. We are adding a 1 to our term that includes the x. So we do the opposite. We subtract a 1. But we have to subtract the 1 from both sides. Is this going to work? These cancel. 2x is less than or equal to 8. We are multiplying our x by 2. So we divide both sides by 2. These cancel. X is less than or equal to 4. Not very different. This one gives x equals 4. This one gives x less than or equal to 4. Nothing very surprising at all, really, when we realize that the questions were really the same except for the symbol. Well, the steps were the same. And they nearly always will be the same. So you can do your algebra tricks that you've learned even when you have inequalities. And of course, there are all these different types of inequalities. We have less than or equal to. We have greater than or equal to. We have less than. We have greater than. It's like there are 5 different symbols that we can put in there, and we've created 5 different problems. But we're using the same techniques for all of these problems. That's cool. So I wanted to compare that. Then, taking a look at my notes, I think I'm going to do a few more like this. So what I'll do is I'll erase the one on the left with the equal sign, and I'll leave that one there, and I'll create another two-step algebra problem with an inequality symbol, and I'll try some of the other symbols. So how about 3x minus 2 is greater than 13. Will this work? It'll work. Okay, so what do? I do the same stuff. My x is being multiplied by a 3, but the term that includes the x is also having a 2 subtracted from it. So what do I want to do? I want to do the opposite of subtracting 2. I'm going to add a 2 to both sides. I find myself saying it faster and faster because I know the students are getting more and more used to it. These cancel. 3x is greater than 13 plus 2 is 15. Now I have to divide both sides by a 3 because I want to isolate my x. These cancel. X is greater than 15 divided by 3, which is 5. I have my answer. It works. Should I test this? Now that we have inequality symbols, we can test. So if this is true, then if x is, say, 6, it should work, right? So let's try replacing x with a 6. 3 times 6 minus 2 is greater than 13. Why did I choose 6? Because that's a number I know is greater than 5. I'm looking at my answer when I make my choice. So this, if 6 is greater than 5, then that means this should work. Unless there's something wrong with the algebra steps I did. 3 times 6 is 18. 18 minus 2 is greater than 13 because 18 minus 2 is 16. 16 is greater than 13. It verifies. Let's try another one. I'm going to keep on working with the same inequality, but I'm going to try a verification with a couple of other numbers. Let's make it interesting. So we chose a number that we knew was greater than 5 when we chose a 6. Now let's choose a number that we know is not greater than 5. And we can even show off and choose a negative number. We could choose a 4 or a 3 or a 2, but we also know, say, negative 3 is not greater than 5. So how about if I do 3 times negative 3 minus 2 greater than 13? What's going to happen? 3 times negative 3 is negative 9. Negative 9 minus 2 is negative 11. Be careful of your laws of signs. Is negative 11 greater than 13? No, it did not verify. This one did. But we knew 6 was greater than 5. We also knew that negative 3 is not greater than 5, so we didn't expect this to verify. So you can test, whenever you're doing algebra with inequalities, you can test by choosing a number that you know has what relationship that number has with your little answer statement. And then you can test both by choosing a number that you know should give you should not verify, or choosing a number that you know should verify. And we may as well do one more example, because what if I choose 5? Now, 5 is not greater than 5. It's close, but it's not greater than 5, so it should not verify. 3 times 5, just plugging into my original question, 3 times 5 minus 2 greater than 13. 3 times 5 is 15. 15 minus 2 is 13. Is 13 greater than 13? No. It did not verify. It was close. It did not verify because it was not or greater than or equal to. It was just greater than. 13 is not greater than 13. So we took a number 5, which we knew should not verify, and it didn't verify. You can even choose the number itself as part of your test to see if your algebra seems to be working. This algebra is working. Okay, that's my next one. I also want to keep an eye on the time and how much other stuff I want to do. And I do have a little bit more time. I'm going to do one more. One more of this style. Not quite so many verifications though. So we tried how about, we had a less than or equal to, we had a greater than. I think I want to have a greater than or equal to. What else can I do that's interesting? I'll put a 10 here. How about negative 4? Should I do this? No. I'm just going to put 4x minus 2 greater than or equal to 10. For now, that's all I want to do. I'm not going to put the negative sign in there yet. So we're doing algebra. We know what to do. We're going to get rid of this minus 2 by putting a plus 2. We're doing the opposite. But we have to do that on both sides. These cancel. 4x is greater than or equal to 10 plus 2 is 12. We divide both sides by 4. I'm going really fast now because I know that you can handle it. 12 divided by 4 is 3. Is x greater than or equal to 3? Well, our answer is that x is greater than or equal to 3. We will verify with one quick number. I will choose something that should not verify. I'm going to choose x equals 1. Plugging that in. 4 times 1 minus 2 greater than or equal to 10. This should not verify because 1 is not greater than or equal to 3. 4 minus 2 greater than or equal to 10. 4 minus 2 is 2. 2 greater than or equal to 10. No, 2 is not greater than or equal to 10. It did not verify, and I did not expect it to. It works. Okay, now I want to do one where I'm going to have a negative sign with my term that includes x, and we will see what will happen. Because although we've just been doing all the same rules with these inequalities that we were doing last time with the equalities, there is one extra little rule that we have to know about. 10 minus 2x greater than 20. Doesn't look very different. But let's see what happens. Okay, so I have my term that includes the x. And it's being multiplied by a 2. And I have this 10, and the 10 doesn't have a negative sign before it, so it means that the 10 is positive. The 10 is being added to this. So I'm doing the opposite of adding. 10 minus 10 minus 2x greater than 20 minus 10. Do on one side what you do on the other. These cancel. I still have the negative sign. Do not lose your negative sign. Negative 2x greater than 20 minus 10 is equal to 10. Now I have to divide both sides by negative 2. These cancel. 10 divided by negative 2 is negative 5. Greater than? Is x greater than negative 5? No. No, we have a rule. The rule is when we divide both sides of an inequality by a negative number, it only happened because it was a negative 2 that we were dividing by, a negative number, we have to flip the symbol. Greater than becomes less than. Let's see if this rule seems to work by trying to plug something. So, x less than negative 5 is my answer. That means negative 5, negative 6, not negative 5, negative 6, negative 7, negative 8, all of those numbers should work. Those are the numbers on our number line, if we picture it, that are less than negative 5. So how about negative 6? This should verify. Let's try it. 10 minus 2 times negative 6 greater than 20. Minus 2 times negative 6, these are going to multiply to give me a 12. Negative times negative is equal to a positive. Remember your laws of signs. 10 plus 12 is 22. 22 is greater than 20. It worked. It verified. So that means that the rule works. That's kind of interesting. So the rule is, whenever you find yourself dividing both sides of an inequality by a negative number, you have to flip the symbol. But not only when you're dividing both sides by a negative number. When you are multiplying both sides by a negative number, you have to flip the symbol. So let's do one that looks like that. Here's a quick little one. X over negative 5 is less than or equal to 2. Okay, all we're doing to this x is dividing it by negative 5, so we have to do the opposite. We have to multiply by negative 5. But we have to multiply both sides by negative 5. We're multiplying both sides of the inequality by a negative number. That's one of the times that we have to apply this rule. These cancel. X is isolated. 2 times negative 5 is negative 10. I have to flip this backwards. Greater than or equal to instead of less than or equal to. Can we feel confident in this? A number that's greater than or equal to negative 10. Let's try to verify. We'll choose a number that's really obviously greater than or equal to negative 10. Let's choose the positive 12. If we plug that in, it means we have 12 over negative 5. Oh, I'm going to get a decimal, but it doesn't matter. Less than or equal to 2. 12 divided by negative 5 is negative 2.4. Is that less than or equal to 2? Yes. If the symbol had been backwards, if the symbol had been, ooh, I've made a mess. I made a big mess. I'm going to fix it. I have to fix it. I don't want to start recording this over again. So I'm going right back up to the top, and I'm doing this over again. I wrote a symbol backwards too soon. Did I write it too? I can't even remember if I wrote it too soon, so I'm just going to redo it. Okay, so my x is isolated. I flipped the symbol. That part I think I did correctly. This is negative 10. Okay, I need a number that's greater than or equal to negative 10. Oh, I had done it right in the first try. Maybe I should edit this out. Okay, so I chose x is equal to 12. And I plugged that in. 12 is greater than or equal to negative 10, but I want to plug the 12 into the original problem. So 12 over negative 5, less than or equal to 2. It is working. I was doing it right all along. 12 divided by negative 5 is negative 2.4. Is that less than or equal to 2? Yes, it is. All negative numbers are less than or equal to positive 2. So therefore, it's verifying. It works when I plug the 12 into the original thing. Okay, so that little mess aside, why? Why are we flipping the symbol backwards? Okay, let's see if I can explain why. Well, I have something over here. Let's remind ourselves that on a number line, the smaller numbers are over here. The larger numbers are over here. We already know that. Okay, so let's try the idea. Let's say A is less than B. And one number is less than another. Let's find an example though instead of using these letters. 5 is less than 8. That's true. We know 5 is less than 8. But what if I divide both of these by a negative number? I will divide them both by negative 1. 5 divided by negative 1 is negative 5. 8 divided by negative 1 is negative 8. Is negative 5 less than negative 8? No. Negative 5 is over here compared to negative 8. So negative 5 is greater than negative 8. That's working. Why is this happening? Because when we find ourselves dividing by a negative number, it's like we're flipping the number line right over, doing a 180-degree rotation to it. Because 8 divided by negative 1 becomes negative 8. 8 was way over here, but when we divided by negative 1, it went over there. Same thing about when we multiply both sides by a negative number. We have 5 less than 8. If we multiply both these by negative 1, we get negative 5 and negative 8. Is negative 5 less than negative 8? No. Negative 5 is greater than negative 8. We have flipped the number line over. We have to flip the symbol to make this work. And that is a kind of a little bit illustration about why you should have confidence in this rule. It does seem like a strange rule, and I have met a lot of students who have trouble remembering it, largely because they don't use it often enough. So the answer to that little problem of forgetting this strange little rule of algebra is do it a lot, and then you won't forget it. Okay, what is on my fourth and final page? I don't have very much time. What is on my fourth and final page? I'm going to remind you of something that we did last week. I'm going to do it very quickly because it is just a reminder that we have choices with algebra. So how about 10 equals 2x minus 6? Well, there's two different ways I can solve this. We were talking about this last week. If we don't care which side of the equal sign our variable is on, then we just go ahead and start doing our rules of algebra, or applying our steps of algebra. We're subtracting a 6, we want to do the opposite. So we add a 6, to both sides. I knew I was going to do that, so I left a space. These cancel. Now we have our 2x, 10 plus 6 is equal to 16. X is being multiplied by a 2, we divide both sides by a 2, these cancel, x is equal to 8. I have my answer. I said it backwards because I don't care if it says 8 equals x or x equals 8. They mean the same thing. But what if I did it the other way? I have 10 equals 2x minus 6. How about if I decide I want to move the 2x to the other side, have the x on the left? So, I have 2x, I subtract the 2x from both sides. These cancel. I have negative 6 over here. 10 minus 2x is over here. Now I want to get rid of the 10. That's a positive 10. It's being added. So I do 10 minus 10. I subtract a 10 from both sides. I do the opposite of adding a 10. These cancel. I have negative 2x equals negative 16. Now I'm dividing both sides by negative 2. These cancel. X is equal to negative 8. X is equal to positive 8. I have a negative divided by a negative. I have the same answer, it's just written backwards. This is just a reminder that we're allowed to do this two different ways, and they're both correct. So now let's try the same sort of thing with an inequality. How about 8, need more chalk, 8 minus x is greater than 12. I'm going to do that two ways. 8 minus x greater than 12. Okay, I can move the 8. I have a positive 8, so I have 8. This 8 is positive. I'm doing the opposite. I'm subtracting an 8 minus x. I am subtracting an 8 from both sides. These cancel. I have negative x greater than 12 minus 8, which is 4. Now I have to divide both sides by negative 1 so that I can isolate my x. These cancel, and I am doing that thing. I'm dividing both sides by negative 1. So I have to flip my symbol into a less than. And 4 divided by negative 1 is negative 4. I have the answer. X is less than negative 4. I know that's the right answer because we have been verifying this before and it's working. How about doing it another way though? How about if I decide I have an x that's being subtracted from this side. I'm going to do the opposite and add an x, but I'm adding an x plus to both sides. I'm doing this now. I'm moving my variable to the right side, which isn't what I normally do, but I'm allowed to do. I'm following the rules of algebra. These cancel. 8 is greater than 12 plus x. But now I need to get this 12 away from the x. The 12 is being added to the x, so I do the opposite. I subtract the 12 from both sides. These cancel. X is isolated. 8 minus 12 is negative 4. I have negative 4 is greater than x, which if I read it backwards carefully, x is less than negative 4. Reading it backwards means you have to read the symbol backwards. So x less than negative 4 and negative 4 greater than x mean the same thing. I just did the same sort of thing with an inequality. What's the difference? Doing it this way, I never had to flip the symbol backwards. I got my variable onto this side so that it would be a positive x instead of the negative x I started with. And by doing that, I put myself in a position where I never had to apply that rule. Over here, I just left the variable where it was, and I put myself in a position where I did have to apply the rule. So this is just another illustration of why we can have confidence in this rule. Because if we follow all the rules of algebra that we've been learning, we can put ourselves in a position where we might need it, or a position where we don't need it. And either way, we get the right answer. We get the same answer. So that works. I'm running out of time. So with that, I'd like to end this week's algebra lesson. I am going to say goodbye. I am going to do my impression of a dog who thinks she's a cat and stretch, because after all that math, I do feel like I need a good stretch. And I am looking forward to seeing you next week. Bye-bye.